So in today's lesson, I want to consolidate some of the ideas that were presented to you in your lab experiment when we looked at the relationship between the angle of incidence and the angle of reflection with respect to plane mirrors. And so hopefully a lot of what we talk about today will seem obvious to you. And if not, it will just kind of help you along in your understanding of the properties of light rays when they hit a flat surface. So first off, the first law of reflection is that the angle of incidence is equal to the angle of reflection. And so hopefully when you conducted your lab experiment and you measured your angles of incidence and the associated angles of reflection, that they matched pretty closely. And any differences that you saw, I'm sure you can think of a number of different sources of error that would have caused some discrepancies between what was measured for your angle of incidence versus that angle of reflection. Notice again, just to review, that we can see that the surface of the mirror is up here simply because we have these hashings at the below the surface of the mirror that indicate where the reflective side is. And the second law of reflection, which may not be as obvious as the first one, but still is worth mentioning, is that the incident ray, the reflected ray, and the normal all lie in the same plane. So remember the other day we talked about what a plane was? A plane is like a flat surface, so you can see this dotted, etched out area here. That's describing the plane that the incident ray is in and the reflected ray as well as the normal. All that it's saying here is that, you know, really if an incident ray is hitting the mirror at a certain point, it's not going to go off at some strange angle that's not in a flat plane. It's going to sort of go in line with the plane where the normal is. And that's if the surface is smooth. And in fact, if it did go off in a different direction, then the plane wouldn't be positioned in the same place. It would be shifted a little bit. So I want to talk about how reflection can change depending on the smoothness of the surface that light is actually striking an object. So if we look at a flat, nice smooth flat surface here, and we examine the incident rays versus the reflected rays, and I look at a bunch of rays that are hitting the flat surface in a parallel fashion. So they're all hitting that surface here, and I can see the point of incidence, and notice that each little incident ray and its reflected ray, there's a little normal line drawn in here showing the angle of incidence and the angle of reflection as being equal. Then I'm going to duplicate that, so I've got 4 rays here, and of course there would be many more rays striking the surface. The point is that you can see that all of these reflected rays are also being reflected in a parallel fashion. And so the fact that they're being reflected in that parallel fashion and then hitting our eyes, allowing our nervous system to interpret it, is going to produce a nice, clear image for us that we'll be able to distinguish. And that special type of reflection has a name. It's called specular reflection. And you can probably, we can think of a lot of surfaces that are smooth enough in the right lighting to allow us to see a nice clear image. And that's just aside from a plane mirror. Things that come to my mind are if you're looking out your window, but the lights are on inside your house, then the light is going to be reflecting off of the window. And then you'll probably see an image, and that's especially true when it's dark outside. Another good example of that would be if you live on the lake or you're out by the lake and it's a really calm night with hardly any wind, then the surface of the water will be very, very smooth enough for you to see your own image. So those are both really good examples of specular reflection that are not caused by a mirror. So let's look and see what happens when light bounces off a surface that is not smooth or polished, that it's a little bit rough, because we still see those objects. We just simply don't see an image of ourselves in it or whatever it is that's being reflected in it. We don't see that. And it's not that the laws of reflection aren't being observed. They are being observed. In fact, I'm going to just take this image and make it just a wee bit bigger so we can see it a little bit more closely. Notice that, the points of indices, the points of contact here with the surface are all over the place. And still, I've also indicated here where the normal is. But the normal line, remember, is at a 90-degree angle to the surface. So if the surface itself is not smooth, the normal lines are going to be pointing in all sorts of different directions. And if that happens, then you're going to see, even though the incident rays are all parallel, because they're hitting the surface at different angles, then they're all going to be bouncing back and not creating that sort of parallel stream of light rays. Right? So like for instance, this surface, this light ray is hitting this surface, but the normal line is pointing upwards, whereas over here the normal line is pointing sort of a little bit to the left. And so the angle of incidence is still equal to the angle of reflection. It's just that the normal line is positioned on an angle simply because the surface is all angled. And so I want to make sure that you have a little bit of this detail written down in your note. So take a minute to write this down as well. So the laws of reflection still apply, but the fact that the surface is not smooth is going to mean that the reflected rays are not going to be able to leave the surface in a nice set of parallel rays, which means that it's difficult for our eye to perceive a nice clear image. And so that has a special name. It's called diffuse reflection. And the word diffuse, I think of like materials diffusing through a membrane, maybe at a different rate. Another way to think about it, if you have a diffuser at home that you might use for your hair, to dry your hair, then that air moves through your hair blower and diffuses or spreads apart. Just like, and that helps your hair to get dry faster, but just like in the same way, the light rays are being sort of spread apart here. So what are some examples of that? Well, if a good example of specular reflection would be like a nice smooth piece of aluminum foil that you might be able to see your image in, then an example of diffuse reflection would be if I took that aluminum foil and I crunched it up and then tried to spread it out flat again, right? There'd be some reflected pieces, but I wouldn't be able to see any kind of clear image. And any rough surface for that matter, whether it's like a cloth-bound book or any kind of dull surface, not without a whole lot of reflective properties, then you're not going to be able to see a nice clear image. I also think of a lake, the surface of a lake when it's a little bit windy out or when it's extremely windy out. The surface no longer being smooth doesn't allow for that nice reflection to happen, and so you're unlikely to see your image. So all of those are good examples of diffuse reflection. And so hopefully we'll be carrying on with our lesson and learning a little bit about how to draw images in mirrors, in plane mirrors today. But in the meantime, while I'm conferencing with some of your peers, I would like you to work on these text questions just to make sure that you're understanding some of the concepts that were presented today in the lesson. And if you have any questions, feel free to ask or come in at lunch for some extra help.